Hello everyone, welcome back to this channel. So let us discuss about spanning trees today. A spanning tree of an undirected graph is a subgraph that is a tree and includes all the vertices of the original graph. In other words, it's a connected acyclic subgraph of the original graph that includes all of its vertices. So we can say that how do we construct a spanning tree? A spanning tree of a graph can be constructed by removing some of the edges from the original graph while ensuring that all the vertices remain connected. So all these vertices need to be connected and there should not be any cycles in the graph. There can be multiple spanning trees for a given graph, and the number of spanning trees can vary depending on the graph's topology. So in definition, we can say a spanning tree is a connected subgraph S of a graph G of V comma E is said to be a spanning tree if and only if S should contain all the vertices of G as well as S should contain V minus 1 edges. So let us see some examples. So here is an undirected graph mentioned in this circle. This graph has 4 vertices and it has 6 edges, right? And it also has cycles in this graph. So when we are extracting a spanning tree out of this graph, number of vertices should remain same as that of the graph. So all these spanning trees, we notice that the number of vertices are 4, whereas even in the graph number of vertices are 4. The second condition was the number of edges should be V minus 1, that is number of vertices minus 1. Number of vertices here is 4. So the number of edge has to be 4 minus 1, that is 3. So you can see all these spanning trees, you have number of edges as 3 and there should not be cycles. None of these spanning tree has cycles, and all the vertices need to be connected. All the vertices are connected here, right? The vertices are connected and there are no cycles in the spanning tree, as well as number of edges are V minus 1 and number of vertices are same as that of the undirected graph that is given. So these are the 3 different spanning trees of the graph that is given here in the example. Some of the applications of spanning tree are in the field of computer networking and in the field of optimization problem. In computer network, a spanning tree can be used to find the most efficient path between two nodes while avoiding loops and minimizing the number of intermediate nodes traversed. In optimization problems, spanning tree can be used to find the minimum weight spanning tree, which is a spanning tree that has the smallest total weight among all possible spanning trees of the graph. So these are few of the applications listed here, and that's all for today's video. Thank you.